you for joining me. This is the first of the level 2 torque calculation problems. Just to kind of refresh you on what we did last time, we did a number of torque calculations where we were given a force and we were given a distance, and we were able to calculate what the torque was as a result. What's different in this case is that in the previous case, if we looked at all the torque values that we calculated, they were generated from forces that were what we would say is perpendicular to the lever itself, meaning that it's 90 degrees. In these problems we're doing, that's not going to be the case anymore. We're not going to be getting perpendicular forces. And so as a result, we need to modify the force that's provided and modify it with the angle given by doing the sine of theta function right here. So the new equation we're going to use is the force times the position vector, or the distance from the fulcrum or pivot point to where the force is applied, times the sine of theta. That angle will give us what the torque value is. So let's begin. We want to calculate the torque on the lever. And so torque, or tau, is equal to the force times the distance times sine of theta. Now in this case, we need to determine what the angle is, because the force we're getting is not being applied right above, perpendicular, or below either. A way of determining what that angle theta is by taking the direction of the lever and then overlaying the direction of the force vector. And we're going to see that in this case, they both point in the same direction or are parallel. Now, when you have a parallel or overlapping lines with each other, we say that that theta value is going to be 0 degrees. Now we can go about solving this problem. The force that's provided is equal to 40 newtons. The distance vector, or position vector, is equal to 1.5 meters. So now we can just plug and chug, where we have 40 newtons times 1.5 meters times the sine of 0 degrees. I'll put parentheses in here to show that it's all multiplied by each other. And when I calculate this, well, I get that 40 times 1.5 is equal to 60, times sine of theta, or sine of 0, which if you hit 0 in your calculator, then hit sine, you should get 0. So now what we have is 60 Newton meters times 0, and as a result, we get 0, I don't want that color, we get 0 Newton meters. And in this case, we don't have to worry about the direction being clockwise or counterclockwise, since it's not turning.